Well, sometimes when we're trying to find the solutions of the roots or the zeros of a quadratic equation by graphing, we'll find that the graph is not crossing the x-axis on a grid line or at an integer, but rather it's somewhere in between. And of course now I guess we're going to use terms like zeros and roots and where the graph crosses the x-axis. The x-axis is the horizontal axis, and we'll use terms like roots and zeros interchangeably. But all of that means, what that means is where is this graph crossing the x-axis? Now on page 231 in the textbook, down on example 4, we're asked to graph a quadratic equation of x squared minus x minus 10, which I have here in the y equals. And when I go over here and look at the graph, I can see that this graph has got two roots or two zeros. It's crossing the x-axis in two locations, but neither of those is on a grid line. It's not exactly this right here is when x is -3. Well, it's not crossing here at -3, but it's also not crossing here at -2. It's somewhere in between. And over here on the right side, we see the same condition existing. It's crossing the x-axis here close to the 4, where x is equal to 4, but it's between the 3 and the 4. And we can express that we've got roots located somewhere between -3 and -2, and we've got a root between 3 and 4, where x is equal to 3 and 4. Now, another way that we can determine this, other than visually looking at the at the graph, is we can go in here to the table. And so if I hit second graph, it's going to take me to a table. Now, what I'm looking for here is I'm looking over here at where y1, and I'm looking for locations where I see a sign change. And right here between the -3 and the -2, and we could see on the graph we were crossing the x-axis between -3 and -2. I see that the value of y for this quadratic equation goes from 2 to -4. So right here I'm seeing a sign change. And that also tells me that I've got a root or a zero between -3 and -2. And then if I look down here, I can see between when x is 3 and 4, I see another sign change. I see it going from -4 to 2. And so these locations where we see y changes, sign changes in the y value, that would indicate a root between these intervals of x. Now, if I want to get a little bit more fine-tuned on this, one of the things I can do is I can change my table setting. Let's say maybe from rather than 1, because you can see it's changing by 1 every time. I could change that maybe to a 10th. And if I look up here, it says press plus for a change in the table. So I'm going to press 1. I'm going to hit plus, and I'm going to change this to 1/10, let's say. And I'm going to hit enter. And you can see that changes my table. And if I scroll down here, I can get a little bit more fine-tuned as to where this root or this zero or this location where this graph is crossing the x-axis. And again, I'm going to look for sign changes. So as I'm scrolling down here, right here, between -2.8 and -2.7, if you look right here, you can see that the y value goes from a positive 0.64 to a negative 0.01. And so now I know that this root is somewhere between -2.8 and -2.7 on the x-axis, and it's pretty close to that -2.7. And if I continue scrolling down, and if you remember we had a zero or a root between 3 and 4, and I'm going to just continue to scroll. It'll be a little bit because I changed that to a 10th. It'll take me a moment to get down there. I can get pretty close to where this crosses the x-axis, where I've got a 0 or a root, whichever term I want to use, between that 3 and 4 mark, that 3 and 4 interval on the x-axis. Okay, so we finally got to the 3s. So I'm looking for where does the sign change. And right here, between 3.7 and 3.8. At 3.8, it's negative 0.01. And at 3.8, it's at 0.64. So I know this is pretty close here. This root, or this 0, is pretty close to where x is equal to 3.7. Closer than even the 3.8. So that's an illustration of how we can visually look at a graph to determine the interval of a root when we're having to estimate it, and also looking at a table. All right, have fun. Great day.